Hi everyone, today we'll be doing question 490 in LeetCode called the maze. So it's really straightforward. We're given a ball and the ball can go through empty spaces by rolling up, down, left, right, but it won't stop rolling until it hits a wall. And when the ball stops, it can choose a next direction. So we're given the start position, destination, and the maze, and we just want to determine whether the ball can stop at the destination. So the idea behind this is going to be a BFS. We're going to use a queue to basically put in every single new possible coordinate, and from there keep on choosing new coordinates to keep moving until we either end up at a destination or we run out of moves. And every single time we reach a destination, we can maybe mark it as visited just so we make sure that we're not reusing any coordinates that we used in the past. So let's get started. Let's push in our start into our queue. Let me just make sure that the start is an array. Cool. And let's say, oh, actually, we should also define our directions too while we're at this. So we can go up, left, right, down. So that's just the four cardinal directions. So 1 and 0, -1. Then we can say while q.length is greater than 0. Let's pop out the first thing in our queue. So let's say let our coordinate xy equals q.shift. And let's check if it's the destination. So if x equals the x coordinate of the destination, which is destination 0, and y equals destination 1, which represents the y coordinate of the destination, then we return true. Now let's move our ball in all four directions. So we can say for let, I'm going to call it dx dy, because dx dy represents change in the x and y. Directions. You can say let x equals direction. Oh, sorry. X plus dx. Next, y equals y plus dy. So remember, the idea behind this question is that we want to go all the way in one direction until we can't go in a direction anymore. So we're going to say while next to x is in bounds, so 0 is less than n, and next y is greater than equal to 0. Next y is less than 0 dot length, and as long as we don't hit a wall, so maze of next x, next y is not equal to a 1, which is a wall, then we keep going in a direction. So next x plus equals dx, and next y plus equals dy. Since we're doing this, I just realized we don't need these two statements. We don't need to add the extra dx or dy. And so let's think about what happens. So let's say our ball starts here and we're going in the down direction first. So we keep going down, and this space is still not a wall, so we go one more down. So do realize that with this statement we're going one out of bounds, so we do have to backtrack one. So we can say next to x dx at the end, and next y minus equals dy. Now to make sure that it's not a previously visited coordinate, let's just mark it as maze of next x, next y equals a 2. So the idea behind this is if we ever hit a non-zero, then we know that we've either visited it or it's a wall. So we can say if maze of next x, next y is not a 0, aka our spot that we landed is neither is a wall or a previously visited coordinate, and we just continue. Otherwise, we just push it into our queue. So queue.push x next y. So if we run out of moves, aka we for some reason visited every possible coordinate and there's no way to reach that bottom, we just return false. Cool. So let's see if this works. Works just fine. And works just fine. Cool. Since this is BFS, the worst case scenario is that we visit every single node, sorry, every single what's it called, space in the matrix. This is all n times m, n and n are the length, and width of our maze respectively. Cool. And so with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.